Here's an example of a rational equation where you have a constant term that is a whole number, no fraction. But the way that we approach all problems that have an equal sign and denominators is to find an LCM so we can clear out the denominators. Remember, the m in LCM is to have multiples. So we can change this x squared minus 16 by breaking it down, difference of perfect squares, as an x plus 4 and an x minus 4. This denominator is one simple factor, if I put parentheses around it, because we can't really factor it. And our 2 right now has a denominator of a 1. So our LCM, after we've made it all multiplying, is to find what's common. And that would be common to all 3 denominators, and there's nothing common to all 3. But we are allowed to write down what's common to some of them. And some of these denominators have an x plus 4, so I write that down just once. And then we go looking for the leftovers, and the only thing left over is this 1, which won't change anything, and this x minus 4, which also must be included as part of our LCM. Now we find an LCM so that we can multiply each term in the problem by the LCM so that we can clear out the denominators. And there are 3 terms in this problem, and each one has to get multiplied by this same LCM. X plus 4 times x minus 4. Now we're multiplying by this LCM to actually eliminate the denominators. So make sure you do this reducing so that you're not left multiplying too much. This denominator only had the 1 in it, so there's nothing that we can reduce. But I'm going to rewrite this x plus 4, x minus 4, and multiply that out as x squared minus 16. Because it was right here. X plus 4 times x minus 4 was x squared minus 16. Now we're ready to clear parentheses and see what we have. We'll have an x squared and a minus 4x is equal to, this 11 is all that's left, everything else has been crossed out. And also, our plus sign there, 2 times x squared is 2x squared, and 2 times negative 16 is negative 32. So since we have the variable on both sides of the equation, we're going to try and get all of our x's together on one side. And I notice that even if I put these together, well, let's see what happens there. We have a negative 4x is equal to an x squared, and let's put this 11 together with this 32 and have a negative 21. Now we have x's still on both sides of the equation, so let's try and get those together, adding 4x to both sides. 0 is equal to x squared plus 4x minus 21. Now to solve this problem, because we do have an equal sign, but we have 2 x's, I call that too many x's, I'm going to try and factor this. But the only time that you can factor is if it is equal to 0. So we'll break down the first term, we'll break down the last term, even though we have a couple of choices, 1 and 21, or 3 and 7. I'm going to go with the 3 and 7 since I want 4. The signs are different, and I want the result to be a positive 4. So if I have a positive 7 and a negative 3, that should work for me. Continuing over here, we're going to go ahead and use the zero product property, where if you're multiplying and 0 is your answer, then one of those factors has to be 0. So we have 2 possibilities. We're going to solve these 2 simple equations. We can add a negative 7 to both sides, and also at the same time add 3 to both sides of that other equation. Here we have x is equal to a negative 7, and x is equal to a positive 3. Now I don't know that these 2 answers will really work in this original equation because we had denominators. So when you do your LCM, sometimes right then and there you also want to do your restrictions. And make sure you know what values the x cannot have in the answer. And x cannot be, for this first factor, negative 4, and for the second factor, x cannot be positive 4. But since those are not the 2 answers I have, these are the answers for the equation that will make it true.